Hello everyone, my name is Puria. I am a University of Waterloo alumni from Mechanical and Mechatronics program defending my master's thesis on electromagnetic field. Currently, I work as a program developer using API of Revit Autodesk to develop tools for Revit users. I've been dealing with programming for a long time now, and I've started with Fortran as a young engineer, learning through engineering concepts, then shifted to MATLAB and C, and after a while I've started using Python. Shifting from old-fashioned softwares to Python that everybody was talking about, and it was supposed to be legendary. Uh, had its own difficulties as I found Python as all the tutorials for Python at least very computer science oriented, and I've decided to create this series of tutorials and videos to help other engineering fellows to learn Python with an engineering approach in mind. So the course is called Python for Engineers for that reason, since I find it very important to be able to think when you approach a problem or a design concept with the tools that you have in your exposure, and the way that you learn a software contributes a lot into it. So I'm here to help you all to understand Python from a numerical computation engine perspective, which I find crucial for any engineer. I'm gonna utilize Google Colab, and for those of you who don't know what Google Colab is, it's a Jupyter Notebook service available for free, and it requires minimum setup from the user, which makes it a great tool for me to use teaching this tutorial and providing my documents and materials. And as I said, I'm gonna start paving the way of thinking numerically about Python. And one of the best libraries available for us that helps us to do so is NumPy, which is originally defined as a library to do numerical operations. Hence, it comes handy for engineers, and it's one of the tools that we use a lot and will enable me to deliver the concepts and materials in a coherent and smooth way. And libraries are usually the mostly used functions in any language that someone has decided to put them together and give them to the user and provide them easily for them. So NumPy is one of those, but it's very powerful and it's widely used. The way that we import any library in Python is using import, and there is a neat concept in Python that we can change the library name to what we are used to. So MP is a widely used abbreviation for NumPy, and that's why we changed the NumPy name to MP using as, and we import it using import. I guess I've just jumped into the tutorial and the materials. A little bit of introduction is I'm gonna try to give you whys and then how and whats, because the whys are actually the things that we seek in this tutorial. We need to understand why we do things in the orders that we do, and that way we will be able to reach to that aha moment that any engineer hopes to reach, where you can decide which tool you need to use based on the reasoning that you have from the problem. And I find it as important as how and what, how to do something and what is required for to do so, because those are the questions that will guide us through the toward that aha moment that we seek uh, through our life. Uh, I'm gonna show you how to use Python, how to communicate with this language, and I'll try to provide examples with even the smallest tools that we have developed and we have learned, and then implement them and solve problems. That way, I find it engaging, and once you see even one or two tools can help you to develop something and tackle a problem, those concepts will resonate longer with you, and it is motivating to learn more about those once you see them in action. So I'll try to have that concept throughout the tutorial as well. I'll try to commit to uploading a video a month, so that way you can see the material at your own pace, and it is not as heavy given my other tasks. I can manage to provide one video a month, and you will be given enough time to watch and learn the concepts at your own pace. Now we can jump in